Today we will discuss about a classification of data and how to form a frequency table. A frequency table will be of two types, that is discrete frequency table and a continuous frequency table. So first let's move on to the classification of data. In the last class we have given a set of classification of data which you all have understood. And today I'm going to give you two more classification. Before that, I would like to discuss why we classify data, or what is the importance of a classification of data, or the main objectives of classifying a data. Now, classification of data, what are the main objectives? It's mainly used for reducing the size of the data and to simplify the data. If you are given a large number of data set, then it's very hard to find out the interpretations from the data. So for that, we reduce the size of the data. Then we have to facilitate a comparison between each variable. If there are more than two variables, it will be very easier to compare the two variables. Highlight some of the prominent features of the data set, and to enable statistical analysis or treatment for further interpretations and further research. So these are some of the main objectives of classifying a data. Now let's move on to different types of classification. First one is qualitative, quantitative. These both are, again, I have taken in the last class, so I hope you all know about qualitative and quantitative. The other two are geographical and chronological data. Quantitative classification. Quantitative data is has a measurable characteristic, as you all know. I think I don't have to explain this much more. For example, the marks obtained by a student, expenditure, income, profit, etc. So now these data can be again divided into two, discrete and continuous. I won't be moving into the further details since I have discussed this in the last class, and you will get the video in my channel. Next is qualitative classification. So this one also we have discussed in the last class. These are data that are classified on the basis of certain qualities and attributes. And the example I would like to mention here is gender, literacy, employment. They cannot be measured. And again, qualitative classification are of two types, that is nominal and ordinal, which I have again explained before. Now here we can only find out how many, for example, we can only find out how many people are employed, but we cannot measure the degree of employment. And your data is divided into two classes, right? So one possessing the attribute and the other without the attribute. So these kind of data, or which possess a characteristic or which do not possess a characteristic, these kind of data comes under these kind of data comes under the qualitative classification. Next is geographical classification. The classification is based on geographical position of a location. For example, the information relating to the number of persons employed in different states of India. Next is chronological classification, the classification which is based on time. And here the essential characteristics is seen, or which is always connected with the chronology or something date related or time related. It's like that. So the importance is attached only to the time factor. Now let's have a look at the example. Population of India from 1951 to 2001 census. So the data between 1951 and 2001, that is, if you are giving emphasis to the time factor over here, then this kind of data is called a chronological data. Now let's move on to the construction of a frequency table. Now, as I said, there are two kind of construction we are going to look forward. First one is the discrete frequency distribution. So this is just an example of how a discrete frequency distribution looks like. So in this table, the first column is the number of children, the second column is the number of families associated with it. Now the number of children, now you have to consider this first column. Here it is 0, 1, 2, 3, 4, 5, 6, etc. Now here I have only written till 6. So this means that what do you think about the data given over here? This is a discrete data. So hence the name discrete frequency distribution. And the number of families, we are not taking this into account right now, but what do you infer from the table? It is nothing but if we go with the first line or the first column, first row, what we infer from this is the number of families. That is, if there are 10 families, then those 10 families in the first row do not have a child. The next line, 40 families have one child, 80 families have two child. So this is the inference that we get from the table. You can infer more, but right now in a first look you will get all these information, but we will come to that later. Again, the total of all the observations is also given in a table, in a frequency table, and here in this case it is 680. Now, in order to facilitate smooth functioning or smooth formation of frequency table, we will use the help of tally marks. And for that we will come to the rules or certain rule sets of how to form a discrete frequency table. Now here we have to count the number of times a particular value is repeated, which is called the frequency of the class. Now I will give an example and then it will become more convenient for your understanding. Now in the second rule set is nothing but in the first column you have to place all the possible values of a variable from the lowest to the highest. So just keep all these things in your mind. Soon after this we will move on to an example. Now in the second column, place vertical bar corresponding to the first column, and those vertical bars are called as tally marks. Now to facilitate easy counting, blocks of 5 vertical bars are kept together. So that also we will demonstrate. The third column, count the number of vertical lines and write down the frequency. So now, keeping all those rules or all those important information in our mind, let's move on to a problem and let's check whether we can form a discrete frequency table. So our example is or our problem is nothing but in a survey of 35 families in a village, the number of children per family was recorded and the following data was obtained. So this is the data set that is given over here. Now as you can see, when you look at this for 1 second, you won't understand anything. So if you have a table format, then it will be very easy to understand what this data set has to tell you. Every data set has a story, every data set has a characteristic. So in order to know the characteristics, first and foremost thing is you have to put all these things in a table format. Now let's represent the data in the form of a discrete frequency table. See, so as I have told you, the first thing that I have done is in the first column I have arranged the number of children in an ascending manner, that is from 0 to 12, and in the second column what I have done is I have given tally marks corresponding to each number of children over here. So how did I give this tally mark? I have a data set over here. Now the number of children is 0. I just looked into my data set, how many zeros do I have in the data set? 1, 2. So I put 2 vertical bars and then I wrote in the third column the frequency, that is 2. Again, coming to 1, I just checked how many ones I have. I have only 1, so I put 1 tally mark and then the corresponding frequency as 1. Second, I come on to the number of children, that is 2. I have here 1, 2, 3 and 4, so 4 tally marks and the corresponding frequency as 4, and here it goes. Now when coming on to 3, I have 6 threes. I found out that there are 6 threes, but you just have a look at this the way that I have written the tally marks. I have kept a block of 5 over here, left a space and then started with 1 tally mark that represents the 6th tally mark. So but I have kept a space over here, so it is if you do a thing like if you maintain this method, that is to keep 5 tally marks in a block, then it would be convenient for you to count the number of frequencies. Okay, and where there are no number, that I have kept it as blank, and then I have written as 0, and the total of all frequencies will add up to the total number of observation. This thing you will have to note. What is it? The total of all frequency is nothing but the total number of observations. So this is in a way of constructing discrete frequency distribution table, but this is only one example. We have a lot of more examples, so this is a simple example. Now we will get certain interpretations from the above problem, so let's have a look at that. I have only written only 4 interpretation. You can interpret more. Now the first interpretation that I have done is, it is clear from the table that the number of children varied from 0 to 12. That is something which I got from the first column. Then there were 2 families with no children. That is something I got from the third column. And 5 families with 4 children each. One family with 12 children. So these are some of the interpretations that I have taken from the table above. Now we'll move on to the continuous frequency distribution. Before moving on to the construction part, we will construct it as along with discussing some important terms which comes under the continuous frequency distribution. Now this is one of the example for a table of a continuous frequency distribution. Here the first column, which if you take a closer look, you can see that it is the weight. This weight is not in kilograms, it is in pounds, so it is 90 to 100. So since weight is it's a continuous data, I have given it as a continuous frequency distribution. So the weight given over here is in the range 90 to 100. So 50 students have a weight of 90 to 100 pounds. Then 100 to 110, that is 200 students have around their weight between 100 and 110. Then it goes on like that. So weight, height, all these things, if it comes under the first column, if that is the variable that is under study, then those kind of the table or those kind of distribution is called as continuous frequency distribution. Now let's move on to some important terms that we will encounter while creating a frequency table, a continuous frequency table. First one is class limits. Now class limits are 2 extreme values of a class within which all the values of a class remain. So here a class means I will come to an example, and then we will you guys will understand what a class is. They are the lowest and the highest values that can be included in the class. The 2 boundaries of the class are called the upper limit and the lower limit of that class. For example, 70 to 79, this is what is called as a class, 70 to 79, and here 70 is the lower limit and 79 is the upper limit of this particular class. Okay, so I hope you understood what class limits are and what class is. Okay, so the next is class intervals. The difference between the upper and the lower limit of a class is known as the class interval of that particular class. Okay, so in this example, in the class 100 to 200, the class interval is 100. Now there is another formula for finding out the class interval or the width of the class that we will come to later. When the certain conditions are applied, we will have to introduce certain formulas in order to find out the width of the class interval. You just can't subtract the upper limits and lower limits and just get the width. No, it's not like that. We will come to that later in a later slide. Now next we are moving on to range. Now here I'm going to give an example. If the salary of 100 employees in a commercial undertaking is varied between rupees 500 and rupees 5,500. That is, suppose if there are 100 employees and their salary range is something. So again, just note that I have told you something, I have mentioned a word called range. So if their salary is between somewhere between 500 and rupees 5,500, this 500 is included and 5,500 is also included, then the range in this particular problem, the range is the highest observation. So the highest observation that we have got here is 5,500 and the lowest observation is here is 500. So the difference is called the range, that is 5,000. So that is how you calculate the range if you are given a set of observations. Please do not do not confuse yourself between range and what class interval. Okay, class interval is the difference between the upper and lower limit of that particular class, but range is something different. It is the difference between the number of observations. So both the ideologies are entirely different, so you have to keep that in mind. Now coming on to the theory part, it is the difference between the highest and lowest value of that variable, of that particular variable or a set of observation that is given. Okay, and the formula is again R is equal to H minus L, H being the highest value, L being the lowest value on the given data set. Now it's class frequency. The number of observation corresponding to a particular class is known as the frequency of that class or class frequency. From the table, so now I will show you a table. Okay, so from the table it is clear that the frequency of the class 1000 to 1100 is 50. So the frequency is 50 of this particular class. And here if we move down to the third class, 200 is the frequency of 1200 to 1300, this class. Okay, so this is 200 is the corresponding frequency of this class. Now what does this imply? This implies that there are 50 persons in the first class. It is said that there are 50 persons who are having income between rupees 1000 and rupees 1100. Now if you add together the frequency of all individual classes, we get the total frequency, that is 550, or the total number of observations, that is 550 in this case. Class midpoint or class mark. It is the value lying halfway between the lower and the upper class limits of a class interval. Midpoint of a class is ascertained as follows. Now you can find out the midpoint by adding the upper limit of a class and a lower limit of a class and divide it by 2. It's as simple as that. Now coming on to the example, if you refer this table, in this example the class mid value of the class 1000 and 1100 is nothing but 1000 plus 1100, the whole divided by 2, you will get 1050. And that is the class midpoint or class mark. It can be also mentioned as class mark. Now how to find the width of a class? So that is something I would like to explain in detail, which I have mentioned when I just took the class of class interval or class limits. Now for that there is a simple formula to obtain the width of the class interval, and the class interval can be, in some cases it can be 50, 10, 100, 650, 500, so something, anything you can get. But how to fix, the confusion is how to fix the class width. So in order to avoid that confusion, we will move on to a particular formula. We will seek the help of a particular formula, and that is nothing but I is equal to H minus L divided by K, where I is the class width of the particular class interval, K is the number of class, and H minus L, I hope you already know, it is nothing but the range, which is denoted by R. K is the number of classes. Now in this again I'm going to take the example of the salary of 100 employees, and here they have given a condition that they want to form 10 classes. Since a condition is given over here, then the class interval would be R is nothing but 5,000. Now how did I get this 5,000? 5,500 minus 500, you get 5,000 divided by 10, that is the number of classes. Okay, so and I get the width as 500. So since I get the width as 500, what will be my first class? So my first class will be 500 to 1000. So rupees, the class will contain people or persons who get salary from rupees 500 to 1000. So here again our class width is around 500. So now since in some cases you won't get K, or they won't give you the number of classes, so how can you arrive at K, or how can you fix the number of K? Now that is what we are going to do next. So according to MA Sturges, the number of classes may be calculated using the formula K is equal to 1 plus 3.322 log n, where n is the number of observations and K denotes the number of classes. Example, if there are 10 observations, the number of classes shall be K is equal to 1 plus, just apply the formula, 1 plus 3.322 multiplied by log 10. So n is the number of observation, and hence you have to multiply it by log 10. Log 10 is nothing but 1, so that is equal to 1 plus 3.322, which is equal to 4.322. Here I'm going to round or approximate this value to 4, okay, in order to get the number of classes. So in this case it is 4 when you take 10 observations. Now let's have a look at another one. If you have 100 observations under study, so if you have 100 observation, again you apply the same formula. The only difference over here is log 100 is nothing but 2, and when you calculate, when you substitute the values in your formula, you will get 7.644, or you can approximate this value to 8, and you get 8 classes. Okay. Now here you have to note certain points. Since we are using this formula to find out the number of classes, it is generally noted that the number of classes is between 4 and 20. It cannot be less than 4 even if n is less than 10, or it cannot be greater than 20 even if n is a huge number or a large number. So this is the one thing that you have to note when you use this formula to find out the number of classes. Now there are also now two methods of classifying data according to class intervals. Now let's have a look at what are the two kinds of class intervals: exclusive method and inclusive method. Now let's have a look at what is exclusive method. When the class intervals are so fixed that the upper limit of one class is the lower limit of the next class. I think we will come up to an example, and I will explain with an example. Okay, now see, it is clear that the income of 50 people in this table is between 1000 and 1099.999. Okay, so here the first column gives you the income, and the first class in exclusive method, if we are using the exclusive method, the upper limit, okay, the upper limit is excluded. So it is clear that the 50 people or the 50 persons income is between 1000 and 1099.999. Okay, so now if a person is having 1100 as his income, he is not belong to this class. Rather, he is belong to the second class, that is where the lower limit is taken into consideration. But again, 1200, if a person is having his salary as 1200, that person is not included in this class. So, and this method is widely used in practice, but it is a bit confusing for laymen. Now let's have a look at what is the inclusive method. Now the upper limit of one class is included in that class itself. So again, I would like to explain this with the help of an example. Again, I'm going to take the same example, but here I'm using inclusive method to create my class. So in an inclusive method, as you can see, there is no continuity between the two classes, whereas in the exclusive method, there was a continuity. Okay, so here if I check 1000 to 1099, the 50 persons included in this class will have a salary including 1099. Okay, we are not excluding this upper limit. And if we come to the second class, again we are including both the limits, 1100 and 1199. The first case also, every case over here, the upper limit is this upper limit and the lower limit both are included. But in the exclusive case, we only consider the lower limit. Okay, so that is the difference, and in inclusive case there is no continuity. Okay, but there's a drawback. If a person has a salary, or if he draws a salary of 1099.99, then so that's a question mark when we use inclusive method, because he won't be included in any class since there is no continuity. So if a case like that persists, you have to use the exclusive method. So again, coming on to which method to use or which one to use. Now for that you have to determine whether your variable is discrete or continuous. If it is a discrete variable, then it is better not to use the exclusive method. If it is continuous, you can use the exclusive method, and if it is a discrete variable, you use the inclusive method. So that is the one way of finding a solution. Now we will move on to what is relative frequency distribution. So till now we've studied about how to make a class, then the frequency, but what is relative frequency distribution? Let's have a look. In order to convert a frequency distribution to relative frequency distribution, you have to divide each of the class frequency by the total number of frequencies. So I will show you an example. And there is one more condition, that the total frequencies should add up to 1, total of the relative frequency, not the total frequency, total of the relative frequency. So let's have a look at the example so you would understand it much more better. So this is the class intervals. Now there are frequencies as before, but how to find the relative frequency, this column, how do you find this column? So this column you can find it out like how. So it is given that in order to each frequency is divided by the total number of observations which is given, or the total number of frequencies. So in this case, to find out the relative frequency of this class, you have to do, what you have to do is to divide 2 divided by 50, you will get 0.04. 5 divided by 50, you will get 0.10. 4 divided by 50, you will get 0.08, and so on. And when you add up this relative frequency, you should get 1. That is the only condition that that you have to take care when you form a relative frequency distribution table. Okay, I hope you have all understood the class. Thank you.